everyone, welcome to part 13 of my video series on statistical significance testing. So in this video we are going to talk about z-test. Now this is probably one of the most popular tests in the world. Now if you want to understand z-test, a prerequisite is to understand normal distribution, but I'm going to present this whole tutorial in a way that you won't really need it. But if you want to look at normal distribution first, I would highly recommend it and you should follow my normal distribution tutorial. And I'm going to leave the tutorial link in the description. Okay, so without further ado, let's dive in. So let's start with an example. We are actually going to solve two examples today. And through those two examples, we are going to discuss how z-test is actually used in order to get statistical significance and in which scenarios. So suppose we collected weights of 100 Bangladeshi men who are used to having fast food. So these guys actually love fast food basically. And their mean weight is 78 kilos, which is probably not much. The mean weight of Bangladeshi men is 75 kilos, it is given, suppose, and the standard deviation is also given, and it is 5 kilos. So basically, what we know here is there is some survey or something, and we know for a fact that Bangladeshi men weigh on an average 75 kilos with a standard deviation of 5 kilos. Okay. Now the question is, do fast food make these men significantly heavier than normal men at 5% significance level? So I think this question makes sense. So basically, we just have to prove whether a fast food or this 100 Bangladeshi men eating fast food, they're actually significantly heavier compared to the average Bangladeshi, right? And 5% significance level means p-value has to be less than 0.05 for the null hypothesis to be rejected. So in this scenario, the null hypothesis and the alternate hypothesis are quite simple. The null hypothesis is that the mean is 75 kilos, and the alternate hypothesis is the mean is significantly higher than 75 kilos. And since we are actually talking about higher or heavier, it is going to be right-tailed test or one-tailed test, basically. Now, the question actually is, how come we are actually using z-test here? Like, what kind of property does this question have that allows us to use z-test? So actually, there are some properties. For example, population standard deviation has to be given. For example, here it is given as 5 kilos. If it weren't given at a population level, then we couldn't use the z-test. Also, sample size has to be bigger than 30, which is 100 here, so it is okay. Then there shouldn't be too many outliers, right? So we have 100 weights right here of 100 men, and it cannot be very skewed or very outlier prone. It has to be fairly like normal. Like by normal, I don't really mean normally distributed, but it shouldn't be like that skewed, basically. That's what I'm saying. So if these properties hold, then we hope to be able to use the z-test. Okay. Now, how do we get the z-score? So this is the formula for getting the z-score. I mean, if you have followed my normal distribution tutorial, which the link I have already provided in the description, you know what this is. This is observed mean, which is basically 78 kilos right here. Population mean new, which is 75. Sigma is a standard deviation of 5. And n is basically the 100 Bangladeshi men. It's 100 sample size. Now, in the z-score that I showed previously in the tutorial of normal distribution, the root n was absent. I'm going to show like why it is actually coming here. But first, let's do the math. So if we plug everything in, it will get a value of 6. So z-score equal to 6. Now the question is why we are dividing by root n. So this is the intuitive logic. So if you have more samples, so here there are 100 samples, you are going to have lower variation in mean measurement. So the mean that we got right here, 78 kilos, with more samples, we are going to have less deviation in this mean, right? I mean, this is obvious because if we had like 5 men, then, and if we sample 5 men from fast food eating men, then there would be a lot more variation in this mean weight compared to if we have 100 men, right? That is why it is lower variation thing. So if you have lower variation in mean measurement, there has to be lower variance, obviously. And for lower variance, you would divide by n, right? So now the question is why root n? Root n is there because we are not really dealing with variance here. We are dealing with standard deviation, and standard deviation is nothing but root over variance. That is basically the intuitive hand-wavy explanation of the whole thing, okay? So that you don't have to memorize this formula completely. Okay, now that we know the z-score, how do we get the p-value from this? Or how do we know whether we can reject the H0 or not? Okay. For that, first of all, we need to know something. We need to know how to use the z-table. So let's actually learn about that first. Okay. So this is a z-table. Now it looks quite hideous. Now let me actually explain how to read this. Okay. So suppose let's look at this particular value right here, which is 0.67364, right? So you can see that there are two z values here. One is z equal to zero point 0.4 and the other one is z equal to 0.05. Actually, you have to combine these two things. Zero point 0.4, so this is 0.4, 0.41, 0.42, 0.43, 0.44, and this is going to be 0.45. So this is the z score of 0.45, and this is basically the area. This is an area, so I'm going to show you it graphically. So you can see that this is 0.45, right? And this whole area is actually 0.67364. So any value that is given in the z table is actually probability of c less than equal some value. Here that value is 0.45 and that value is 0.67364. I hope this is clear to you. It is always going to be the left side area. Okay. So it's sort of like a cumulative distribution function. Let me also show you another example. So here there are the negative z-scores. So let's also see another example here. So suppose we are looking at -2 and 0.05. That means minus 2.5, right? -2, -2.1, 2 point, not 2.1, I should say 2.01 basically. -2.01. So last of all, -2.05. So if we take those numbers, so here you can see that this should be -2.05, by the way. I'm sorry about this mistake because this is 0.05. So this is going to be -2.05, mistake right here. So this value right here, 0.20, this is nothing but the left sided part, right? This area. This tiny area is going to be 0.02018. So probability of z less than equal -2.05, this will be 0.5 by the way, is equal to 0.02018. So this is what the z table represents. So now that we know how to use the z table, let's actually see how we can deal with the z score that we got. We got a z score of 6. So what does that represent? So let's see that. Okay, so we have this table right here. We know that we are actually working at a significance level of 5%, right? 5%. So basically we need to look at the extreme 5% region, right? Extreme 5% region. So we know that this is a one-sided test. We are trying to see whether these guys are heavier. That means whether these guys are on the right side, the right extreme, right? So somewhere right here, right extreme. So at this side, yeah, at this side, like if you look at some value at this side, then you have to get the area at this side, right? So let me clarify what I'm saying actually. So when we are trying to look at the top 5% right here, the extreme 5%, right? You know that this table is not for the right-sided area. This table is actually for this left-sided area, which is basically 0.95 or 95%, right? So where is 0.95? If you look at here, this is actually the first time 0.95 actually comes into play, and this value is 1.65, right? So this is going to be 1.65. 1.65 is the critical value. So beyond 1.65, everything falls in the extreme 5%, right? Which is the critical region. Now our value 6 that we got is actually bigger than 1.65. That means it falls to the right side, to the red side actually of this value. So it falls in the critical region. That means p-value is going to be less than 0.05 because this region right here, only 5% people fall in this region, and 6 is more to the right. So it's going to be even less. And so null hypothesis is rejected. So fast food does make men heavier, right? So basically we have proven this fine. So this is an example of a one-sided z-test, right? One-sided. And we are talking about the right-sided here. Now let's look at another example. So this time we are going to look at an example of two-sided. So suppose we collected the lifetime data. Lifetime data means that when people die, basically. When people die, then we take their age, like at which age they died. We collected lifetime data of 30 poor men in Bangladesh. So these are poor men. And their mean age is like 68 years. The mean lifetime of BD men is 70 years with a standard deviation of 8 years. These are all made up numbers, but the thing is these are given. So the question is, do the poor men have different lifetime expectancy from typical Bangladeshi men? Right? Now understand that here we have written different lifetime expectancy. We haven't written less or higher. We haven't written that. It can be less or it can be high. Doesn't matter. Okay. So this is the hypothesis. Null hypothesis is nu equal to 70 and alternate hypothesis is nu not equal to 70, and it is two-tailed, as I said before, two-sided. So Z-score calculation is very easy. Now I want to warn you about one thing. There are 30 poor men, so we are in the danger zone, right? Because we barely have enough samples, right? So that's fine. So if you plug in these numbers, you're going to get something like minus 1.37. Okay. Now it's time to see whether this value falls in the critical red region, right? Okay. So if that's the case, let's look at this. Now, obviously, we can see that there are two tables. One table is here for the positive Z values, and one table here is for the negative Z values. Now, why exactly are we doing this? Because this is a two-sided test. So we care about the extreme top and the extreme bottom, right? So this is the extreme bottom 2.5%. This is the extreme top 2.5%. So at 5% significance level, if our calculated Z score falls in any one of these red regions, then we can reject the null hypothesis. So if we actually do the math, and if you look at the Z table, you can see that 1.96 has the value of 97.5%. So this is where like the left side, I mean at this point the whole left side is going to be 0.975 area. And here in the negative part you can see at minus 1.96 right here the value is 0.025. So this is the bottom 2.5%, right? So the critical values are these minus 1.96, 1.96. Now I just want to give you a disclaimer that you don't really have to like look at both tables right here because the normal distribution is symmetric. So you can just get one value and just plug in the other value as positive of that, okay? Or like negative of that, whatever you do. So I think, I mean, this is just to show that it works like that. Now, the thing is, you have a value of what? Minus 1.37. Minus 1.37 falls somewhere right here, right? Somewhere right here. And obviously, it is not falling in the critical region. It is falling in the normal region. So p-value bigger than 0.05. So we cannot reject null hypothesis. And so being poor has nothing to do with difference in lifetime expectancy. So this is the entire Z test. I hope you like the video. I hope that this video is probably the most comprehensive one out there. So if you like the video, feel free to subscribe and share, and you can subscribe to our channel via the link in the description. Thank you very much.